So far, so good. Okay, so I think people have enjoyed our OpenGL videos. Okay, so this is, I believe, people would have marked that the transformation what we are achieving in OpenGL. So that is something that it's a kind of we have invented or we have written. So what is a special thing that we are using in the OpenGL transformation? So there are two kind of transformation in OpenGL. So I would say the kind of transformation coordinate in OpenGL. So one coordinate is like is called fixed or grand coordinate, and one is called object or local coordinate. So there are two ways that we do the coordinate system in the transformation in OpenGL. So if we see, like if I have a axis, means x, y, z are the axis. So if I have axis, and then if I do the rotation, translation or scaling, then it happens with respect to the axis. So if I rotate, then it takes the x-axis as a kind of it's the line on which it would rotate. Means if I rotate along the x-axis, or if I rotate along the y-axis, then it rotates along the y-axis. If I rotate along the x, y, z axis mixture, then from the fixed axis origin it will draw a line, and around that it will rotate. So this is the kind of fixed or grand coordinate system. So that is the idea. And another is object or local coordinate system. So object local coordinate system is means each object they have their own axis. Means it's a kind of funny, or it is very different. So if I have 10 objects, if I go for grand coordinate, grand kind of coordinate system, then all 10 would do the transformation considering the real axis x, y, z as its reference. But if we do local, local coordinate system, local coordinate system, the 10 objects they have their own coordinate system. So if I have a sphere, and if I say now please translate to another location, then since it has its own axis, so it will go at that location along with its axis. Now if I say now rotate 90 degrees, so this is origin, object came here, and if I say rotate 90 degrees, it would rotate there only, because axis is local to the object. But in the grand coordinate system, if I translate and if I say rotate, then it would rotate around the fixed axis. So that is the difference between the local coordinate system and global grand coordinate system. Okay, means there is no problem. So if we write the code and if we use the transformation commands like translate, rotate, scale, and then finally we draw the element, how we read it. So if we read from top to bottom, then it's a game of kind of just keep doing the transformation, because each transform it completes to a matrix. So once we start the transformation, generally we set the identity matrix, and then we start doing the transformation. Then based upon each transformation, then finally it maps to a matrix, and then matrix multiplication starts happening. Matrix multiplication is not kind of reflection, means A into B is not B into A. Means please go through our matrix tutorial. So matrix generally, when we see matrix, it is row and column, and one is input and one is output. So if you multiply two matrices, generally input to the media we multiply to get the output. Okay, so in the input matrix and the media, so row and column they correspond to a kind of input and output. So we cannot flip each other. So that becomes that becomes nonsense or of no use. So matrix cannot be flipped. So it cannot be swapped. So A into B is not B into A. So now if I write the transformation commands from top to bottom and draw the item, and if I start doing the matrix multiplication anyway, whatever OpenGL does, it does. But if I start reading the commands from the top to bottom, and at the end we come up with the kind of a particular model view transformation matrix after doing the computation, and then that becomes a local coordinate. So for each object we draw whatever the set of commands that we write, so that comes as a local coordinate. But but if we read reverse way, draw the item, and then from bottom to top start reading the transformation command, then means program is same. Then it happens, it follows grand coordinate system. If we read from the top, start from the matrices, then draw the item, it is local coordinate system. From bottom, draw the item, and then from bottom start the matrix multiplication, then it becomes grand coordinate system. So problem, good thing about grand coordinate system, there is one coordinate. So if you draw 10 items, all would do transformation along a fixed axis, translation, rotation, then full. If I rotate item here and then translate to some, it will go somewhere. But if I follow a local coordinate system and then so if I follow grand coordinate system and if I rotate the item, since fixed coordinate is not rotating, so even though after rotation, if I translate into x direction, it will go in fixed x direction. If I translate in y direction, it will go in fixed y direction. Okay, but if you follow local coordinate system, if I rotate the object, its axis gets rotated. Then if I translate it to x direction, it won't go in x direction. It would go in a direction which is the new x direction. So that is the difference in the local coordinate system and grand coordinate system. Okay, so why the discussion is? Okay, sometimes we need to follow the local coordinate system when a drawing is complex. Okay, like there is a robot, or like we have drawn so many solar system. So there is a planet Earth, and then it's a satellite Moon. So wherever Earth would go, Moon would go. So then Moon would rotate around. So wherever Earth goes, its axis travels with it. So Moon follows it. So when we go for kind of recursive kind of, I would say complex kind of drawing, then we follow the local coordinate system. So very nice. And then otherwise simple grand coordinate system we follow. I mean, this is how we understand the problem. Where the problem comes, means the program is same and it matters of understandability, then where problem comes? Problem comes when I have an aeroplane and then I follow local coordinate system and it is going in its own direction. Okay, by bad luck, if it starts rotating, I don't remember the term, then, okay, so this is aeroplane, the aeroplane is going and then it will start rotating on its own axis. So this is local axis. But what about I want to rotate along the fixed y axis? Not possible. If I follow local coordinate system, then getting back the fixed y axis. So if I say this is the kind of the plane at the origin, if I rotate it, okay, then x axis came here. It was here. Now it came here or it came here. Now if I translate, okay, nice, or if I translate along x, it would go this direction. It should have gone this direction, but it will go this direction. And if I rotate, it will tilt like this, then I'll move. If I now rotate along y axis, it will move like this, because this is the local y axis, x axis and z axis. Now what about if I move things like a local coordinate system and at some time I want to do it in grand coordinate system, then local coordinate, then it's impossible. Means since we write the code from one point of view, that either it is local coordinate system or grand coordinate system, we cannot mix both. How we can mix it? Okay, so that is the question. So how we can mix it? Okay, So that we'll see that at runtime, like OpenGL is a game of vertices. So at the end it comes to matrices. So how we understand the matrix and how we can mix the coordinate system global and local at runtime. So that will